There we go. Hey there. Welcome everybody once again to Astronomy Daily Live. It's 2 hours UTC and it's time once again to gather together this group of friends, this ever-growing group of friends. I actually noticed the other day, or was it today, that I've got 178 subscribers. So that's I mean, I'm not I don't really have any kind of subscription goals or anything, so I don't really pay attention to those kinds of things. But I think in the past year I've probably picked up about 100 or so. Um, so and I, I I don't really know if that's good or bad. I do, I mean, my primary goal here, right, is to share a passion. Uh, the more sharing I can do, I think, the better this this whole thing will be. So that's sort of my only gauge. And I was looking at the views, and the views are sort of, I don't know, they're sort of all, sometimes there are quite a few, and sometimes there's just a few. So I don't know what kind of correlation there is there. I don't have a clue. As I said, not really paying much attention to that, except just sort of a curiosity thing. But what I'm doing here is pretty much what I've been doing for years and years and years and years and years, and that is this time of day at my locality here. It's sort of the early evening. It's the end of the day, and I'm just sort of chilling out, relaxing. And what I've been doing for many years is sitting right here, getting onto the computer and looking at all kinds of astronomical things. So looking at papers and just sort of following my nose, right? So if I see anything interesting during the day, I'll sort of make a note of it and do some investigations now. So really, the only difference between what I've been doing for a very long time and now is that one, I've got you here joining me, and two, I'm talking out loud. Like I've said or mentioned many times, I'm a pretty quiet dude. So I this is definitely the most number of words that I speak in the entire day. I probably say more words during this hour-ish or so than I do throughout the entire day. So that's. But besides that, what we do here is we just think and talk and investigate all things astronomy and space and science and all kinds of nerdy things. And this live stream is a daily one, starting at 2 hours UTC each and every day. So if you're new here, make sure to subscribe. You can hit the notification bell. You can hit the thumbs up if you like it. Let's see. Make sure to share this around. Spread the word, right? Because, like I said, my primary goal is to just sort of share this passion, right? And I've got a lot of passion to spread around. So the more I can share that with, I think the better. At least the better I'll feel. So and if it turns out that you learned something or come across something new, I think that's absolutely great, right? But that's sort of what I'm going after too. Is I'm just trying to look for new things, look at old things, just following my nose, and I am taking you along with me. So welcome. I'm really glad that you're all here. I'm going to check the chat really quick, see who's there. And while I'm checking the chat, I want to say howdy to Bobby on the panel once again. Hey.
Once again, yeah, and just want to let you know that this is a Jesus stream.
Really? How so?
Yeah, because like you know about that troll yesterday.
Yeah.
He's always like praising the glory of Lucifer. But just want to let you know, just give you a warning right now. This is a Jesus stream, you boron.
Well, I guess I'll take support from wherever I can. So that sounds okay to me. That's perfectly fine. So hey there, Ert Radio. Nice to see you in the chat. And Tom is back in the chat. Very good. Excellent. So cool, Ron. The Sky Portal app works well. So that is very cool. You can my understanding is that you're able to control your telescope through your smartphone app. That is pretty cool. That is pretty cool. That maybe opens up some possibilities. At least I guess you don't have to mess with the paddle, which this thing. But you can. I think you can see that. So at least you don't have to mess with that thing, which is okay. But yeah, if you can have it on your smartphone, I think that is very cool. So yeah, you just gotta get some clear skies now, so you can jump onto that learning curve a little bit more. Do the sky alignment and make sure the telescope is level and all of that. So cool. Well, definitely keep us posted. And I know pretty much the first clear night you're going to be out there taking a look. Like I said, it might be a little bit of a struggle at first, but maybe not, right? I mean, everybody's experience is different, and like like I've said, and like I'll say many times, and this is a recommendation to anybody who is doing anything new at all, is just be extremely patient with yourself, right? Because it's really easy, to sometimes get frustrated. But the fact of the matter is, for the most part, these machines are doing exactly what we tell them to do. And sometimes we just don't know what we're doing. So I'm going to check my weather too. It is cloudy here, and
no, tell me why my weather was saying it was going to be rain and stuff.
Yeah, well, it says that it is raining at your zip code there. I don't know if it actually is or not, but
that's why. Yeah, my Accu weather app says there's some rain right now.
Huh.
And it's saying it's going to end in less than 20 minutes.
Cool, cool. Well, you know, best weather report is to walk outside and look up too. So I
Ain't
recommend
that the
that.
truth?
I recommend that
I
too.
don't.
But
They're saying by tomorrow we're gonna get some thunderstorms, including Wednesday as well.
oh, okay,
That's
yeah,
usually the omen.
yeah, yeah. So yeah, last night I was hoping that it was going to clear up, and it kind of sort of did, but then the humidity shot way up, and it was actually when I shut down, I think it was at 82% again. So it's like, wham, just absolutely no good at all. And there were still, by 9:30 local time here, there were still some high clouds in the area. So I'm just sort of like, I'm not going to do it. Carolina
Uh,
Sky Astronomy, hey, nice to see you there.
Welcome,
Excellent.
Caroline Sky Astronomy with Long Invested.
Yeah, glad you could come in. Cheers.
And the Curious Cannabis Connoisseur.
Hey there, Curious.
The Good Stoner.
Nice to see you again. Yeah, most stoners are pretty good. So it you know just like most people, right, are generally good people. So regardless of what the label is, um, most people are pretty awesome. So yeah, good. Glad everybody could come in again. So yeah, last night's session was a no go again, and I think we're supposed to have clouds here for the next couple of days. So no more observing for me. So but that's how it goes. All right. Well,
I just
cheers. So
love like one day when the lights will definitely will have like a power outage. It'll be just be a clear sky, and you definitely can see the band of the Milky Way.
yeah, yeah. Well, this time of year, early evening, it's going right overhead. So it's a nice time, to be out. So yeah, definitely, if you get a chance to get out where it's dark, at least, you will
Yeah.
definitely see it. Now, this time of year, we're actually looking. Uh, uh, sort of out of the Milky Way, right? The center of the Milky Way is sort of in the opposite um, direction. So we're actually looking outward, right? I mean, if you can sort of visualize that, right, as opposed to looking towards the center of the galaxy, we're looking in the opposite direction. So uh, uh, and it's a little thinner, right? There aren't quite as many stars looking out that way as there are looking that way, mainly because of our location within the galaxy. That sort of um, uh, gives us an idea about where we are in terms of the galaxy. The fact that when we look towards the center, we actually see more stars, and the Milky Way is brighter. Um, and when we look this way towards Orion, we're actually looking in the opposite way, and we don't see as many stars, and the Milky Way is fainter, and that ratio, right, gives us a rough indication as to where we are within the galaxy. Hey there, Mr. Beast. Picking my nose? Yeah, well, it's a habit, that I just have gotten into. And actually, most astronomers do that. So you know, I'm just doing the astronomy thing. So welcome, Mr. Beast. Nice to see you in the chat as well. Definitely a newcomer in here. So yeah, glad to see you. Glad to see you. So everyone, grab your favorite consumable, whatever it might be, and let's you know, um, take some of this and let's get into some astronomy, huh?
Yeah, let's do it. Are we
All
still
right.
on Leo or something?
We're still in the constellation of Leo, but what I wanted to do actually before we got into that, I went over to the um, to the to the to the research notes of the American Astronomical Society, RNAAS, and I noticed that there was a kind of an interesting, at least to me, a new paper, um,
Cheers from
sort
the
of a
UK, Andy
hey.
Cowley.
Hey there, Andy. Nice to see you. Cool. Very, very cool. It's these.
From USA to the UK, yeah.
Yeah, absolutely. Absolutely. Yeah. So yeah, let me I think I'm gonna do that first because this looked a little interesting. It, I mean, when I look at papers, right? Research papers, um, the first thing I do is I look at the title, right? And if the title looks interesting, then I'll look at the abstract, right? And the abstract is just like a very, very brief, like executive summary of the entire paper. Well, these research notes don't actually have abstracts. They're so short, um, they're supposed to be just short and sweet, 1,000-word things. You bang them out, they publish them in a couple days, and that's it, right? So it's all you have is the title. And so here I will share my screen, and we will go over and look at this one that caught my eye. So it says a surprising and colorful Martian scattering artifact. Now, that has 3 words in it that I really, really like, right? One is the word surprising, right? So that grabbed me right away, right? I absolutely love surprises, right? Love surprises. Um, the other word that I really, really like is colorful, right? I love colorful. As you can see, and I'm going to switch to this really, really quick here, right? This is my background screen. This is a solar spectrum, right? So this is a spectrum of the sun taken with a special kind of a spectrograph called and a shell, ESCHELLE spectrograph. It's extremely high resolution. So what they do is they sort of stack the full spectrum like this, right? And so as you can see, it goes from very, very red to very, very violet, right? So it goes through the entire visible wavelength band. And what we're actually looking at are the absorption lines of whatever stuff is in the sun, right? And as you can see, there's a lot of stuff, tons and tons of stuff, right? And these bands are wide and narrow. Some of them are really, really dark, and some of them are really, really faint. So all that kind of information tells us things about this star, what the temperature is, what the conditions are, how much of a certain amount of stuff there is, all of that. But as you can see, I think that this is absolutely fabulous, right? And so, yes, I love color, right? So when there's a title like surprising and colorful, it's like, man, I am stuck, right? But there's also the word Martian, right? I mean, Mars is pretty awesome too. So I want to see what this is. Now I saw this about half an hour ago, maybe an hour ago or so, and it it was almost impossible for me not to click on this and see what it was. But I resisted. I definitely did. So here we go. This is what it's all about. Um, I'm, you know, um, going to click on this for the first time so we can share this experience together. That's a nice thing, to do, is to have shared experiences. So here we go. Let's see what this surprising and colorful Martian scattering artifact is. I'm totally intrigued. So let's see here. So as I said, these research notes are really, really, really short. They're intentionally really, really short, just to sort of give a extremely brief synopsis of whatever they're doing, right? So let's see. This thing was submitted, or actually received on February 18th and published on February 22nd. So just a few
I would
days
like
ago.
to welcome the lovely Atalanta.
Hey there, Atta. Nice to see you again in the chat. All right, so here we go. Let's see what this is all about here. So despite considerable imaging and frequent observations of water and CO2 ice aerosols as clouds in the atmosphere of Mars to date, there have been no proven observations of a halo, rainbow, or glory. Oh, okay. These optical effects would be particularly valuable if they would indicate that these aerosols taken on a regular crystal microstructure, um, um, informing us about the dynamics of the Martian atmosphere and the nucleation of ice crystals at small scale. Critical information for Mars climate models, given how frequently they are observed on or with the terrestrial atmosphere. The absence of such optical scattering features on Mars is puzzling. Okay, so in examining the Mars Color Imager, Marcy data set, I don't know where Marcy comes from, but maybe we'll try to find out. We are therefore drawn to images containing an apparent rainbow effect. So an example is shown in figure 1A, in which a bright linear feature is observed which changes in color from top to bottom along the image. Okay, so I think these are, I'm not quite sure what BGOR and N are. Maybe we can find out what BGOR and N. Opposition surge of the 5 visual filters of the raw images. Okay, so yeah, these are different filters, and I guess this thing is sort of moving along the ground. Oh man, I want to know what Marcy is. The opposition surge had, okay, well, here. Let's, does it say anything else up here? Bright from the changes in color from top to bottom along the image. Okay. Okay, so blue, green, orange, red, and near infrared, right? Okay. I'm kind of curious as to why these things sort of curl around at the end, but okay, oh, okay. So this is the scattering angle. Okay, I got you. So scattering angle versus intensity. Huh. Versus latitude, north, 1, 2, and 3. So I guess what is this sort of the feature that they're talking about? This thing where it's sort of red over here and green over here? Oh, I don't know. Let's see, we have to think about this a little bit. So panel A shows the location of the visible opposition surge in the 5 VIS filters, which I guess would stand for visual filters of raw image that, and the composite image produced from the red, green, and blue filters with the 3 analyzed cross sections highlighted. 1, 2, and 3. Oh, okay, so here's 1, 2, and 3. Yeah, wow, this is sort of a complicated diagram here. I'm going to zoom out a little bit. We're really majorly zoomed in. So they've taken the red and the green and the blue, and they've combined them into this composite. And then they've plotted these things, these little white boxes here. These, I think, are 1, 2, and 3, but oh man, I'm not quite sure. This obviously, I don't know if it's obvious or not, but this sort of looks like a polar cap, right? So this is the North Pole or the South Pole. I'm not quite sure which one. Scattering angle goes from 80 degrees over to, well, almost to 180. So, yeah, I guess I'm not really understanding these diagrams very much. And I mean, I'm pretty dense, so who knows? Anyway, so panel B displays the results of the analyses showing that different filters quantitatively observe the opposition surge at different latitudes within the swath. Okay, so 1, 2, and 3 are different latitudes, right? So here, here, and here. And I guess there's these little arrows there. What are these black arrows? I don't know what these black arrows are. And they seem to be pointing to particular lines. You see how this one, I'm going to zoom up a little bit here. Oh, is it trying to do it? Yeah, it's not doing a very good job. See how this black arrow is pointing to like this line, and this arrow is pointing to this sort of orangey line, and this arrow is pointing to this blue line. Not quite sure. But I mean, there are differences in intensity. All right. Let's see. Panel C provides the planetocentric latitudes corresponding to the observed SAs. SA. I don't know what I don't know what an SA is. Um, All right. Let's see if we can gather a little bit more info here. So this linear feature is brighter than its surroundings as a result of a phenomena called the opposition surge. Scattering angle, okay, which is observed at a scattering angle of 180 degrees when the sun is directly behind the observer. The opposition surge has been observed frequently on both the Mars orbiter camera and Marcy data. On the surface, the scattering characteristics of Martian airfall dust in the atmosphere and on the surface are well known and cannot produce the observed color effect, which initially led us to consider thin and meridionally varying clouds with different mixtures of ice and dust to be the source of the feature. However, a deeper analysis showed that rainbow-like features of this kind in Marcy data arise from a subtle artifact. Once the image was calibrated as per these methods, a spice kernel algorithm. Spice is a piece of software that's sort of available, which took into account spacecraft geometry and camera optics was employed to determine that the scattering angle from left to right along 3 cross sections in each of the 5 filters. Surprisingly, the 180-degree scattering angle occurs at different latitudes in different filters. Okay. Yeah, well, that's kind of cool. It's kind of cool. So, yeah, they're seeing something. This variation in scattering angle at with the filter wavelength arises from the geometry of the Marcy camera. While this instrument is used in a push broom configuration, each of the filters are mounted on Marcy CCD in order of increasing wavelength at different angular distances from the optical axis of the instrument. The location of each pixel on the CCD affects the viewing geometry, which can vary by up to a 26-degree long track. When the multi-filtered push broom swaths are converted to separate filter frames, this difference in viewing geometry produces an offset in perspective and therefore the latitude of the 180-degree scattering angle observed in each filter. Well, that's pretty cool. So yeah, I guess as an expected use, the sensitivity to sensitively probe the width of the opposition effect at subpixel scales as the surge is smeared out along the spacecraft ground track in each 2-degree wide filter. For the image described in figure 1, this produces a half-width, half-max opposition surge radii of 3.42 degrees and 3.93 degrees in the blue and green filters. Oh, okay. Well, so I guess, yeah, for sure what they're seeing is something interesting. But yeah, I'd have to take some time to really understand what they're talking about exactly. But it's sort of looking like, you know, they're seeing this brightening here, which is sort of coincidental to a scattering angle when the sun is right behind the spacecraft. So yeah, kind of interesting. Kind of interesting. Pretty cool. Pretty cool. All right. Nifty. Nifty. And I guess, well, I guess it's a surprise because they definitely weren't expecting that. Do they say anything about why they think that's happening? Because it's kind of interesting, you know, because they're talking about the opposition surge, which has been observed. I guess I'm not quite seeing what is new here, unless they've just never seen this before. But that's kind of cool. It's subtle, right? It's pretty subtle, but there's definitely something there. And like I said, this is, I don't know, this is a difficult set of figures here. Gonna have to really think about this a little bit to understand what exactly they think they're seeing. But kind of interesting. Kind of interesting. Huh. All right. Well, let's move on. I noticed that there was actually, we're talking about the constellation of the month being Leo, and they're actually talking about a EXO Comet host. And I think this is a lowercase Greek letter theta, I think. But they're saying no detection of cold dust. No detection of cold dust. So, yeah, and actually that's one of the other purposes of these research notes is to say, nope, we didn't see something. So that's actually, I mean, not seeing things is almost as informative as actually seeing things. So that's pretty cool.
So there are two comments about when you did that scattering artifact. Caroline Sky Astronomy. I know every time I shot Mars last summer, the color always seems to be different, even though I was shooting with RGB. And also, Laura to ask, did Mars have a dust storm last year during its closest approach to the Earth? As she recalled, the dust storm screwed up her billing for some time, and I think that was a really bad one and stuff.
Yeah, there actually was a dust storm last May and June and July. So yeah, absolutely. Now, I'm going to claim ignorance in terms of the color changes on Mars. Not quite sure. Mars is rotating, so you would sort of expect slightly different colorations every time you look at it. But yeah, I mean, if it's going to be, I mean, if you're noticing, significant differences in color, that's kind of interesting. I don't know. kind of neat. But this I think let's actually go over and I'm pretty sure that Marcy is a let's go Marcy Mars like that. Mars color imager. Let's see if we can find out where this thing is. Marcy. Okay, so yeah, Marcy is, it looks like one of the instruments on the Mars Reconnaissance Orbiter, right? So HiRISE is one of those two, right? We oftentimes look at images from HiRISE, but Marcy is just a different instrument. Kind of an interesting looking photograph there. I'm not quite sure what we're looking at. So Marcy produces a global weather map of Mars. Oh, okay, yeah. You know what? I think I've seen these. I think I've seen these maps. Latest Marcy weather report. Let's take a look. Yeah, yeah. See, so this is sort of a global view of Mars from last week, right? And this actually makes a little movie. So I suppose we can
roll film.
We can try to roll film here and see see if it brings my system to its knees or not. Well, it doesn't really. So okay, yeah, I think what this does is it just looks at big strips, right? Big huge strips from almost north to almost south, and that's kind of cool. So this is where they're seeing that sort of rainbow effect, right? At different latitudes, they're seeing different colors, and well, that's kind of cool. Yeah, I think I've seen this before, and so yeah, this provides an interesting look at the Martian weather as it changes over time. And these aren't like high resolution images or anything, but they give you a relatively good idea about the global thing. And as you can see, the date here is changing, right? So every single day you can see. So here's February 17th, and it goes around once, and then it flips to February 18th. Oh, that's the end. Okay.
And if you look at the top of the page, there's like a caption image release for potentially today.
Oh, okay, cool. Yeah, let's why don't we take a look at that, huh? I don't know what we're gonna.
Back.
Yeah,
takes you back.
Yeah, I think. Yeah, I'm not quite sure.
What the hell is taking you back?
Oh, I don't know. Not too worried about it. 2020. Yeah, I think. Not quite sure. I guess this is the date that this data was released, right? So it takes them a week or so, to process things and take a look themselves and all of that. But very cool, very cool. So yeah, this is definitely a way, I would say, to be able to see any of those interesting and surprising rainbow patterns. I think it's kind of interesting. You know, I don't know what how they're creating these color images, but yeah, there's a lot of what I would call blue in these things, right? It looks like there's some clouds up here, right? Way up at the north. You can sort of see those. They go away after a while. There they are again. So yeah, kind of cool to be able to see clouds and different, weather things on Mars for sure. But yeah, so that's where this data has come from, right? What we were just looking at. I guess these long strips, right? We'd have to get into the actual instrument, but it sort of looks like to me, that maybe these are like very, very wide angle lenses of some sort that, are able to see, the whole surface at the same time, or just a strip of it, right, from north to south. And some of them are obviously missed, but that's pretty cool. Pretty neat. Yeah, I don't know if you all noticed or not, but let's see, where is that? There was a let's go to my Discord. Let's go over to the Discord here. There was a where did I put that? I never remember where I put these things, but I posted a link to the new Martian weather station being provided by Mars Insight. And I don't remember where I put that now. If it's over here somewhere. No, I don't remember where I put that. Wow. Anyway, so let's try to find that really, really quick. Mars Insight mission. Mars Insight lander. They actually have pretty up-to-date weather over there now too. Here's the weather report. I don't know if that's what we want or not, but let's take a look anyway. Yeah, there it is. So this I thought was pretty cool, right? They show the temperatures and the wind speeds and the pressures each and every day, and very much updated, right? This is just a couple of days ago, right? And then they actually show little 3-day plots as well, showing the same thing. The air temperature, the pressure, and the wind speed, right? So pretty cool.
And right to welcome Ray Rael he was in lurk mode.
Hey there, Ray. Nice to see you in the chat. Glad you could stop in. We're just looking at some the weather report from Mars Insight. So it's pretty cool. They're showing highs and lows, and
I would love the feature that you'll be able to switch it to Celsius. Maybe for international viewers, we might find out what it's in Celsius.
Yeah, I think that's kind of neat too. So actually, it sort of looks like, looking at things here, right? That it just in the last day here, the wind speed started picking up a little bit, and it actually looks like it was getting a little bit warmer too. So kind of interesting. Yeah, it'd be interesting, and I mean, I'm sure this is being done, plotting these things over longer time scales, right? Over months and over years and all that. They're going to be able to get lots of interesting information about that. I think it's kind of interesting how the pressure, um, you know, reaches a peak right after sunset and reaches a low, or I'm sorry, right after sunrise, and then reaches a low right before sunset, and at sunset, it just bam, it goes way up again. So that's kind of interesting. I don't think that's what's happening on the Earth. Not quite sure, but that's pretty regular, right? This pattern, sunrise, pressure rise, and then it slowly drops during the day, and then at sunset, bam, it just bashes back up again. Pretty stable overnight, and then right at sunrise again, it um, creeps up a little bit, reaches a peak, drops all day long, and then at sunset, bam, it just crashes again, goes way up again. So that's kind of interesting. And I think it's really, really neat too that they're showing not only wind speed, but wind direction, right? So that's kind of cool. It's kind of cool. It looks like, for the most part, it's sort of always blowing in the same way, but there's some variation there too. So pretty neat, pretty nifty, nice stuff. It's really, really amazing to be able to sit here in sort of the comfort of our own homes and see, you know, at least at this location on Mars, right? This is a different planet. This is a completely different place, right? Like nothing on Earth at all. I mean, literally like nothing on Earth. And we're
And I
seeing,
guess like Mars is super cold. It's flip, huh?
well, it's a little cold, but I mean, everything is relative though. Um, uh,
It's kind of
there's
like a bit awkward that it will go from like almost warm to super cold and just in a Martian soul.
yeah,
That's
yeah.
crazy.
Well, there's no atmosphere, so the heat just radiates out, and um, um, cooling in a radiative way is very, very efficient. So yeah, that's absolutely true though. Is that you know you're going from pretty darn warm, almost tolerably warm to us, almost, 10 degrees Fahrenheit. That's you could be out there for a little while, if you bundled up, right?
Yeah,
But yeah,
it's kind of like a bit
um,
crazy here in Louisiana. If everything like goes below freezing, everything goes south. Highways close, school closes, all that
mhm.
other stuff.
Oh yeah, absolutely. Yeah,
And our school board system is trying to stop that.
yeah. Well, I mean, it sort of depends on the environment, right? I mean, if you're not used to freezing temperatures, um, it could be, relatively dangerous, to move around and travel with ice and all that kind of stuff. So, you have to be equipped, right? To deal with those kinds of things. And if you aren't, it's probably best, just to call it a day and stay home, right? I'm a little bit used to large temperature swings here in the desert Southwest. Oftentimes, um, during the summer, right? We'll break 100 degrees Fahrenheit during the day and drop into the 40s or 50s at night. You know, these temperature swings are obviously a lot more, right? 140 degrees Fahrenheit temperature swings. That's a little extreme, but yeah, you know, that's what happens when you don't have a lot of atmosphere and all that. So yeah, pretty cool. All right, so there's Marcy. Hello, Marcy.
Remember, it's Marcy, not Marcia.
Yeah, I'll have to investigate this a little bit more. Um, because yeah, I assumed that the planetary data system probably, if we go over here and look for a data release from the Mars Reconnaissance Orbiter, is that where we're? Yeah, it's the Mars Reconnaissance Orbiter. Let's see, do we see anything from Marcy here? Nope, I don't see anything Marcy there.
I can see the Mars Reconnaissance Data 47 is there, which will definitely include Marcy.
Yeah, there it is, right there.
But not your HiWise.
Yeah, they have a lot of data, so I think they sort of break this up a little bit. But yeah, here's some Marcy data. So yeah, I mean, if we're ever interested, we could dive into this a little bit. Mars Color Imager, is that it? I think this is Marcy. Yeah. So let's see. This is if one were to go over and grab this data, this is what you would see. It's not sometimes not the prettiest in the world. Sometimes, yeah, this format is a little difficult to deal with, but there it is. That's sort of the raw data that you have to contend with. So it's just these long strips, and each of them have a little code word, right? And you have to know exactly what that is in order to get the right stuff. So yeah, it's sort of a task to just grab the data you want, and sometimes that's a difficult thing. But if you want it, you'll get it for sure.
Yeah.
All right, well, cool. I think let's I'm looking at the time and I'm noticing that we're coming up to the top of the hour. I guess probably what we should do is maybe look at something from Leo really quick. There are a bunch of Messier objects. I think there's like 5 Messier objects in the constellation of Leo. I should check my chat here really quick. Starting to get lower in the west. Yeah, Orion is on its way down now for sure, coming out of winter. But yeah, let's I guess let's sort of quickly just scan the Messier objects in the constellation of Leo, and then maybe we can do a closer examination of them over the next couple of days. Because yeah, it is getting near the top of the hour, and I'm about halfway done here, so it's not really crisis time yet. But yeah, let's I'm gonna pop back over to here to the Wikipedia page for the constellation of Leo, and we can quickly just sort of look at the Messier objects over there. Right. So we've got 5 of them. Right. We've got M65, M66, M95, M96, and M105, and they're all galaxies. Right. All of them. So probably, I guess what we should probably do is just sort of quickly look at them all. And then,
right now, is that Stargazer Moonshine?
What's that?
Oh, that's that. Look at the check the chat.
Well, you know, I'm going to leave that ambiguous. So this is definitely a wonderful elixir here. So it's made primarily from a single molecule, though. So a single simple molecule. So this is definitely my go-to. And yeah, you know what? I think I could call it Stargazer Moonshine for sure. So cheers. Close shot of M43. You know, M43 is the kind of object that is sort of like if you get M42, you usually get M43 for free. So you know, right in the same field of view. I think I've you know, I'm not too keen on sort of these common names, but I think M43 is sometimes also called the Running Man Nebula. I think that's M43. It's right next door. So yeah, you might check that out. As far as a close shot goes, don't know. Yeah, you'll have to investigate that a little bit. So yeah, let's dive into and actually, I think what might be best, maybe even funner, is to look at some astrophotography photos of these galaxies instead of looking at the HST images or the Sloan sky survey. Let's go over to
yeah. So CSA, he had a shot at M42, but wanted to get closer to M43. And Altawada has said it is one of nature's crude jokes that some of the best sky viewing comes in the middle of winter. When I'm viewing in the winter, she'll drink the real moonshine.
yeah. Anything to keep you warm, for sure.
So, well, not just real moonshine, but usually like hot chocolate.
Yeah, and Atta, I think what you're saying there is sort of a matter of opinion too, because the best sky viewing, I don't really have a favorite time of year in terms of that, because the fact of the matter is that except for a relatively small slice of the sky, you can observe any object any time of year, right? Now, of course, when the sun's in the way, it's kind of hard, right? But you basically just have to be willing, to get up at weird times, right? I mean, if you want to observe Orion in the summertime, right? You can do that, no problem at all. But you just have to wait, right? You have to wait until the time of night is such that the constellation Orion is up. Yeah, I sort of disagree with that a little bit, because most things are up anytime you really want to. It's it's just a matter of, if you've got to wait, till 4 in the morning to see something, well, you're going to have to wait, right? So let's see. Which system, mix aligning, telescope, and yeah. Oh, Ray, I definitely have mosquitoes, but it is nothing. It is nothing like what others have to deal with at all.
Oh my gosh, when we had to deal with mosquitoes, it's like a nightmare.
Yeah. See, here, the mosquitoes are kind of annoying for a month or two, maybe. But it is definitely not a nightmare, and yeah, no problem at all, really. But
you better watch some of the. You gotta watch some of the mosquitoes as well around here in Louisiana. Some of them may carry that west now.
Oh yeah. You got to watch it. You got to watch it. So, but yeah, I'm again, I'm in a very, very benign environment. So even as far as the bugs go,
well, I guess when you look at the chat, I guess mosquitoes are everywhere.
Mosquitoes are everywhere. Yeah.
My goodness.
But yeah, and some of them are, I've heard in the deep south, right? They're like the size of B-52s, right? They're like just absolutely huge too, or just big swarms of them, right?
More of a swarm than a B-52 style.
Hmm.
We're gonna need a Power Rangers Megazord to take that and squash that big bug.
Yeah. And it's not really, that they don't survive here. It's just not. It's not their place. I mean, it's usually way too dry, right? We'll get them during the monsoons, but that only lasts a couple of months, so no problem at all. Okay, so I've gone over to cloudy nights, and I'm going to share my screen again because I don't want to take up too much time here. And let's just grab or look for some.
Kind of wait for you, Deep Sky Do, unless you are also was in lurk mode.
So let's go over to cloudy nights, and I'm just going to search for M65 and see what comes up here. It's searching. Waiting. Come on. We need the music here. Dun, 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 we need the cloudy nights music.
Oh, there it goes.
Here we go. Huh. I don't know why I'm seeing all of that. Huh. Well, let's do this a different way. Let's go to the photo gallery here and see. Is there a way to search? Yeah. Let's just do M65 in the photo gallery. So here's what they call the Leo triplet, which is M65, M66, and NGC 3628. And let's just see here. So that's sort of a small view, but here's 65, here's 66, and here's the NGC object here. It makes a nice triangle in the sky. That's kind of small, though. Let's.
Oh yeah, I think Ray wants you to have a star party at your location. I hope you brought the deet.
Yeah. So there we go. Hold on, I'll be right back. I'm being summoned at the door. Hold on. come on, I hear you. You should have come in earlier. Yeah. Hello. All right, here we are. So yeah, here's M65, M66, and NGC, what was it, 30? I forget exactly. Yeah, so here's two of the Messier objects in Leo, two spiral galaxies. This one looks like a maybe has a little bit of a bar in there too. Both at an angle, right? We're sort of assuming that all of these spiral galaxies are actually round, right?
And this is Cloudy Nights he's on. Maybe you
Yeah.
can post the link into the chat for a run.
Yeah. So cloudynights.com. Ron, I highly recommend getting onto that site because they're a very active group, extremely helpful. So if you have any kinds of questions with your scope or anything, I would say go here first and post a question. It's a very active forum and very friendly, very helpful. Yeah. Anyway, so yeah, three spiral galaxies. This one we're seeing it almost edge on, right? So we're actually seeing this dark material there. And then these two, we're seeing at some oblique angle, right? So like I was saying, these spiral galaxies we sort of assume are pretty much round, circular, right? But because we're seeing them at some inclined angle, they sort of look like that, right? So, all right, let's see if we can see any other interesting ones here. So here's, yeah, there we go. So here's 65 and 66. This one is 65, I believe, and this one is 66. Seeing a little bit more detail here. There we go. So pretty nice, yeah. So there is definitely a bar there. Do you see this straight part here that goes right through the nucleus, and then the spiral arms are sort of spiraling off of that. Not quite sure here. It's a little bit harder to see because it's inclined a little bit more. So we're seeing this one a little bit more edge on than this one. Pretty cool. Pretty cool. All right. So let's look for M95. M95 and M96. Here's some drawings that people have done, but let's see if we can find some photos. So there's M95. Now it looks like he's got some flat field problems. You see these dark circles here. That's from either improperly applying a flat field or not applying a flat field. So these are artifacts inside the optical system. So yeah, not the best shot in the world, but you can definitely see that this galaxy looks pretty much face on, and again it's got a nice bar through it and a ring. So wow, that's pretty awesome looking. Let's see if there's any other ones here. 95. I'm not quite sure. I'd like to. Not quite sure what this I'm not quite sure. This is not quite sure why it's labeled M95 here. It's kind of a weird label. That is definitely not M95 any stretch of the imagination. There's a pretty nice shot. There we go. That's pretty nice. Got some color in there too. So again, you know, it looks like maybe it's not quite face on, right? Because we're seeing sort of an oval shape here, but pretty spectacular. And you can see how star-like the center is, right? I mean, it looks like a. I'm going to zoom in a little bit here. I think I can do that. Can I? Well, I can't with that, but I can with this. Well, I'm trying to at least.
And of course, there's always downloading it and using an image viewer.
Yeah, yeah. But that would be way too easy. I would much rather struggle with this. Anyway, yeah, very, very star-like nucleus there. That's pretty cool. Now, when you look at this through a telescope, right? These are, I think, did it say here? Yeah. See, so this is 8 60-second exposures, right? So you will never ever see this like this when you look at it with your own eyes through a telescope, right? You won't. What you'll see through a telescope is basically just this central area, right? You're really not going to see this out here at all. Maybe you'll see a little bit of fuzz out here, right? But what you're basically going to see is just this very, very near in area here where it's brightest, right? So you'll see a bright nucleus with some fuzz around it, and that is basically what you're going to see. These are, you know, long exposure photographs, which of course, you know, they accumulate the light, and so, you know, you can see a lot more. So you know, that's one of the things that a lot of people are sort of disappointed with, right? When they get a new telescope, they sort of expect to be able to point at, you know, these objects and see this, right? No way, never. You'll never ever see it like that, right? Even through a big telescope, right? Even through a big one, right? You're not going to see this, right? This you're only ever going to see when you take a long exposure, and these are actually stacked, right? You know, so you know this person has taken 8 1-minute exposures and then added them all up, right? So but you know, it definitely brings out, you know, the details, and pretty nice there. Yeah. Let's see if there's a couple of others. Okay, so here's M95, M96, and 105 all in one field of view. Ooh, that's nice. Cool. Now, I'm not quite sure which one is M105, but I would sort of assume it's the brighter one here. Right, so here's 95. Let's see if we can, oh, that's not going to help much. So here's 95 here, right? Here's M96, and here's M105. And it actually has a couple of friends. Leo, as I said, is very, very rich in galaxies, lots of galaxies. Lots and lots of galaxies. So yeah, nice to see that. And again, you know, when you look at M96 with your own eyes, through your scope, you're not going to see a lot of this detail. You're going to see a little faint, little smudgy thing right there. And same with 105, right? You might be able to notice a difference though between what you're seeing with 105 and what you're seeing with these two, right? Because the morphology is different, right? These are spirals. This is a elliptical galaxy, right? Doesn't have any spiral arms, doesn't really have any structure, right? It just sort of has a shape. And that's because there is no or very, very little gas and dust in these galaxies. I don't really think anybody really knows why. It's just sort of happened that way. I'm sure that there's a lot of theories. But yeah, that's a pretty good shot. It's a pretty good shot. This kind of looks interesting. It doesn't look like a star, right? I'm sort of looking at the other stars around it, and they're sort of, yeah, this might be a star, just really, really bright, so it's a little overexposed maybe. But yeah, that's a pretty nice shot. Pretty nice shot. So yeah, those are the 5 Messier objects in Leo. We should definitely take a closer look at those. Go over to Sinbad and take a look at those too. But I'm definitely noticing the time, and I always say that I like to keep this to about an hour or so, but going 90 minutes or so is probably the limit. So yeah, I think it's about time to get out of here for now. So I'm gonna check the chat really, really quick one more time, and yeah, definitely Ray, M65, 66, and that little NGC object. For most amateur size scopes, you definitely should be able to see all 3 of those in the same field of view. And I have, and yeah, it's very, very cool, and it's really, really interesting and amazing to think about what you're seeing. Right, you're seeing 3 different galaxies, right? I mean, we're in a galaxy, right? And within this one little tiny region of the sky, we're actually seeing 3 of them right in the same field of view. So yeah, it's mind-blowing, absolutely mind-blowing. All right, everybody. Well, I think I'm going to get out of here for now, so take care. Let's do this again. I will be here once again tomorrow, 2 hours UTC, and we'll do more astronomy and be guaranteed equally confounded by the universe. That's what I like most about it. Is that it's just it is definitely a mystery, and we're trying to understand things, but I don't think that we ever will. I think if we ever do, yeah, maybe it's time to hit the reset button then, right? So, but I don't see us doing that for quite a long time. So, all right, everybody, cheers, peace, and all that. I will see you in a little less than 1 spin. Bye.